Hello. We are doing our last section in the entire semester. We are solving radical equations. So what that means is we're solving for x. We are going to have square root signs in it or cube root signs. We're getting rid of radicals. That's it. That's what we're doing. Mostly pretty easy. Pemdas in reverse. That's how we're going to do that. Not really that big of a change from anything else we've done. Maybe one or two little twists to it, but for the most part, it should make sense. Here we go. Anytime we are trying to solve, you might have heard me say this before, anytime you are trying to solve anything, the best way to do that is isolate the radical and raise both sides, blah, 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 blah. PEMDAS in reverse, that's what we're really doing here. Okay, so we can talk in fancy math language, but PEMDAS in reverse is what we're going to try to do. All right, so if we're looking at this first one, we're going this way. I'm going to try to add and subtract. So the first thing I'm going to do is get rid of the negative 13. I'm going to add 13 to both sides because this is what I'm trying to get by itself. I got to get rid of everything else to get that by itself. So I added 13. So when I get 4, the fourth root of 2x is equal to 4 when I add 4 to that. Then I need to get rid of the fourth root. To get rid of the fourth root, I'm going to do the opposite of the fourth root, which is raise everything to the fourth power. Fourth and fourth root are going to cancel. I'm going to have 2x is equal to 4 to the fourth power. This might not be one you're familiar with, but 4 to the fourth power is 256. So nothing new about this problem. Divide by 2, divide by 2. We got x is equal to 128. So here's what we did. We added or subtracted first. We couldn't multiply or divide yet, so we skipped that step because the next thing we had to do was get rid of the root. Everything was underneath that radical sign. And so before I got to that 2x, I had to get rid of the root first. The opposite of the fourth root is fourth power, so I did that to both sides. Once I did that, then I had 2x. Then basically I was going inside the parentheses. I'm going underneath the radical inside the parentheses to do my final step of dividing. 128. Again, nothing that crazy about it. This one's a little bit more strange. We're going to solve, get rid of the square root. Well, I want to get x by itself. It's on both sides. If I want to get rid of x, I'm going to get rid of the radical. And how do I do that? I square both sides. So the good news is this problem becomes really easy. X plus 8 equals 2x minus 2. By squaring both sides, I just don't care about that stuff. All I have left is this. Then I'm going to solve just like we always would. Subtract x, I get 1x minus 2 is 8. I'm going to add this 2 to the other side, add 2, x equals 10. If I plug in 10 over here, I would get the square root of 18. If I plugged in 10 over here, I'd get 2 times 10, which is 20, minus 2, which is the square root of 18. That is a true statement. Boom. You can always do this kind of stuff on Desmos. Let's show you because I think that's kind of cool. So if I did this and I graphed the square root of x plus 8, and you're not great at these graphs yet, we'll do this in second semester, but that's what a square root graph looks like. And then we're saying it's going to be equal to the square root of 2x minus 2. Well, there are my two graphs. You've got the green graph and the red graph. Guess where they cross? They cross at x is equal to 10. That's what we're doing when we're solving these things. Okay, we're finding that x value that makes it true, but we're also just figuring out where they cross. That's what we're trying to find out. Because if they're equal, they intersect. Let's keep going. PEMDAS in reverse. So add or subtract first. Get rid of that plus 3. So minus 3, minus 3. Square root, 2p, 7. Then I'm going to square both sides because I added or subtracted. The multiply divide step, well, it's underneath the radical, so I'm not doing that. Then I'm going to exponent. The radical is an exponent step, so to get rid of the square root, I squared. I squared both sides, that cancels. 2p, 7 squared is 49. Divide by 2, divide by 2. P is 49. Divide by 2, perhaps. 49 divided by 2. You could leave it as 49 divided by 2. If you want to go a decimal, that's 24.5. Same difference, both work. Letter B, PEMDAS in reverse. I'm solving for x. Here's x. Is there an add or subtract step outside of this radical? No, so we're going to skip add and subtract. So the next thing we're doing is multiply divide. Sometimes this is kind of weird because you're like, is that a root or not? That's why I tried to make it clear here. It's 3 times that. So now I'm just going to divide by 3. That's it. 18 divided by 3 is 6. And then I'm just back to normal. All right, next thing I want to do, I multiplied or divided. Next thing I got to do is get rid of the exponent. To get rid of the radical, I square it. 5x plus 1 is 36 minus 1. And then divide by 5, x equals 7. Just step by step, working through and getting rid of pieces. All right, next thing, same thing, only difference here, instead of radical, they have it written as a fractional exponent, a rational exponent. So we're still doing Pemdas in reverse. We're going to add or subtract. There's not one. So then we're going to multiply or divide. Well, to get rid of this 2, I'm going to divide both sides by 2. X to the 3/2 power. 250 divided by 2 is 125. So we multiplied or divided. Now we've got exponents. This is 3/2 power. And remember what 3/2 power is. 3/2 power is the square root cubed. All right, I want to get rid of that. The easiest way to get rid of that is to raise it to the reciprocal power. I'm going to raise it to the 2/3 power. Because the 3 on bottom, that's a root, would get rid of the cube. The third root and the cube would cancel. And it's square rooted, so I'm squaring it. I'm raising it to the second power. And also, if you multiply 3/2 times 2/3, you are going to get just x. It'd be x to the first power. Then we got to do this, 125 to the 2/3 power. You technically could use your calculator, but you don't need to. That is 125 cube rooted, because of the root on bottom, and then I'm going to square that thing. Well, the cube root of 125 is 5. 5 squared is 25. All right, so again, I just did 125 to the 2/3 power. Boom, 25, just like I thought. All right, so again, to get rid of 3/2 power, we raise it to the reciprocal power, so we did 2/3 power. Let's do it again. X plus 5 to the 1/2. 2x plus 5 to the 1/2 is equal to 4. Remember what 1/2 power is. If something is to the 1/2 power, that is the same thing as the square root. All right, so if I want to get rid of the 1/2 power, I'm going to do the opposite, which is 2. Okay, 2 over 1, if you want to write it 2 over 1. Well, that's how I would get rid of a square root as well. I would square it. Okay, so I'm going to do that to both sides. Over here, it's going to cancel. 4 squared is 16. Then I'm getting rid of piece by piece. Next thing I'm getting rid of is the 5. And then I would get rid of the 2. 11/2 is perfectly fine, or you could write that as, what is that? 5.5? Yeah, 5.5. All right, that's it. Let's run through a couple more just so we see it. PEMDAS in reverse. We'll do one more here. PEMDAS in reverse, we're going this way. There is no add or subtract step because that one's inside of parentheses. Next, I'm doing multiply divide. It's squared. Okay, one thing that students do sometimes is they'll try, do not do that. That's bad. Do not distribute that 2 in there. That's completely wrong because it's to the 3/2 power. Instead, I'm going to get rid of it. It's being multiplied by 2. So what's the opposite of multiplying by 2? Dividing by 2. Get rid of it. X plus 1 to the 3/2 power is going to be equal to 54 divided by 2, which is 27. Then I'm getting rid of 3/2 power. The opposite of 3/2 power is 2/3. Over here, it's going to cancel. Over here, I'm doing 27 to the 2/3 power. 2/3 power means the cube root of 27, which is 3, and then 3 squared, which is 9. Just kind of thought of this. Let me... Nope, okay. I was trying to see if something happened. All right, let's do this last one. So I'm going to divide by 2, divide by 2. 8 divided by 2 is 4. To get rid of 2/3 power, I'm going to do 3/2. X minus 2 equals 4 to the 3/2 power. So think about what that is. The square root of 4 is 2. And then 2 cubed is 8. I'm going to add 2 to both sides. X equals 10. But that's not it. Because think about what we did here. By doing this, by raising it to the 3/2 power, it's like I'm square rooting. And so this gets a little bit funky here. And maybe it'd be even easier to approach it one at a time. But that 2 is square rooting. Well, what is the square root of 4? The square root of 4, when we're solving here, is 2 and -2. Then I need to cube that. Well, if I cube 2 to, oh yeah, that's getting me 8. But -2 cubed doesn't get me 8. -2 cubed gets me -8. And then I'm adding 2 to that as well. I get 10 and -6. I get 2 separate answers there. And the reason is because I square rooted it. To get rid of that 2 power, I had to square root. I didn't have to worry about that here because to get rid of that power, I was cube rooting. And here I cube rooted. Okay? Just a matter of working it from that point. So 10 and -6 are going to be my answers. Just so you see it visually, here's a graph of what we just did. The x minus 2 to the 2/3 power times 2, that's this V-looking graph. That's not something you have to be familiar with. But when I make it equal to 8, notice that it has 2 sides to it. I get one answer there at -6 and another answer there at 10. This is not a skill that you have to be great at. It is not something that's going to pop up a bunch, but just be aware of it. If you square root something as you solve, you're going to have positive and negative. And then we get to these, where if you understood what I just said, this might get a little bit tricky, but let's do it. All right, it's like before, but we're got to check our answers. So if I were to solve this problem, I would get the square root of 5x minus 9 equals, I'm going to add to -4. Then I'm going to get rid of the square root. To get rid of a square root, I'm going to square both sides. And then I take -4 and I square it. That is going to get me positive 16. I got to square that with the negative on the inside. That's positive 16. I'm going to add 9. I'm going to divide by 5. X equals 5. At first glance, you might think, oh yeah, I'm good. The answer is 5. But it's not. All right, this is kind of a strange concept here. If I were to take 5 and plug it back in, so let's plug it back in. 5 times 5 minus 9 minus 2 equals -6. 25 minus 9, that would be the square root of 16. The square root of 16 is 4. 2 does not equal -6. This is something that, for me as a math guy, I'm good at math. This thing always blew my mind when I was in high school. Why, when I took the square root of 16, did I not write plus or minus 4? Well, here's the rule that you should think about, all right? A square root graph, when I graph it, is only going to look like that. It's going to only be positive, okay? If the square root sign is already there, like right here, when I have that square root sign and it's already there, if you take the square root sign and it's already there, it is going to be just the positive version. That is different than like what we did here. When it was 4 to the 3/2 power, that was like 4 square rooted and then cubed. We made the square root sign to get rid of the square. If that happens, you need both the positive and the negative version. And the reason is because I'm squaring it. Okay, we're doing the opposite of squaring. The opposite of squaring has to have a positive and a negative value. Because think about what a square looks like. A square looks like that. It's going to have a positive and a negative value. Okay, that is different than a square root. So all of that is to say this. If you are solving a radical problem and you have a square root sign, and to get rid of the square root sign, you square it, and you are squaring a negative number, that is not possible. Okay, you are not going to have an answer for this problem. The answer to this problem is no solution. Because when I plugged 5 back in, it did not work. All right, so if I went back to here and I graphed that thing just so you could see it. So the square root of 5x minus 9, and then we had a minus 2 out here, and we were trying to figure out when that was equal to -6. It's not equal to -6. Here's this graph, this blue line. Here's that green line, that's -6. If I zoom out, you can see that these two lines are never going to cross because it's not a negative version as well. If I put a negative version in there, negative square root of 5x minus 9, yeah, now they touch. All right, now they're going to intersect, but that's not what the problem said. All right, the problem didn't have a negative sign there, so it's only going to be the top version, so they are not going to cross. So again, if you have to square a negative number to solve, it's not going to work. All right, let's try another one. Get rid of, oh, just playing. Add the 2. Add the 2. The cube root of x minus 7 equals negative 1. To get rid of the cube root, I'm cubing both sides. That cancels. Negative 1 cubed. So negative 1 times negative 1 times negative 1. That is negative 1. Add 7, x equals 6. This is going to work. I could plug it back in if I want, but it's going to work because I didn't square a negative. I cubed a negative, but cubing a negative is fine because if you cube a negative 1, it's still going to be negative 1. It's the even exponents, like 2's and 4 roots, that's going to give us an issue. So just so you can see it, again, I graphed the cube root, so I got to get a little fancier here. I don't like doing cube roots. Cube root of x minus 7? Now, what was it? Yeah, x minus 7 minus 2, and I was trying to figure out when that is equal to negative 3. Well, it's going to be right there, okay, at that spot right there. And again, that's an easy problem because a cube root graph goes both to the left and to the right forever. So it is going to intersect, and it is going to work. So that one is fine. This one right here, let's solve it. So I'm going to subtract 2, subtract 2. The square root of x minus 3 is equal to negative 5. I'm going to get rid of the square root. I'm going to square. That should put off an alarm in your brain. I get x is equal to 28. But I had to solve this radical by squaring a negative. 28, if I plug it back in. 28 minus 3 would be 25. The square root of 25 is 5. Plus 2 would get me 7, not negative 3. So the answer to this problem is no solution. They are not going to cross. Because in order to square, I had to square a negative number. All right, a little bit strange. Let's do one last one here. This one's not going to have the issue because it's cube rooted. If it was fourth rooted, we might have to play with it differently. All right, add 6. So negative 3. Get rid of the cube root. I'm cubing it. Q minus 4 equals negative 27. It's fine. I cubed a negative number. There's no issue there. We're still going to be able to solve. I'm going to add 4. So Q equals add 4, so negative 23. If I plug negative 23 back in, I would be good. Strange concept. I'm not going to do this last one. This is a long video enough anyways. I don't want to wear you down. It's just a matter of solving. You got some weird stuff here with pluses and minuses. I'm not that concerned with it. Don't be overwhelmed with that concept. But the main idea is when you're solving, PEMDAS in reverse. You're done with first semester. Great job. If you have questions, ask me.